Hey there, Akuma fans. Charlie with the Gossamer Applications staff with another tip for you. It was recently brought to my attention that of all the videos I have on YouTube, I have never talked about doing graphic tooling displays for Akuma mills. I've got several on the lathe, but nothing for the mills. So here we go. I figured I'd remedy that problem right now. Before we even start, I'd like to point out to new Akuma users that this is entirely optional. What I'm about to do is completely optional. The only reason that you need to go through these steps is if you want to see an accurate depiction of what your tool looks like in the tool data page. This little window right here can show you a picture of your tool, and it will also display the what the cut looks like in your animated simulation window on the front of your OSP P300 control. If you don't want to see this, or you don't need to see the graphic verification, all of these steps are irrelevant. What we can do, if we are not interested or we don't require seeing the graphic up here, is one time I'll come over to the tool data page, and right now I have no tools registered in the machine or in what we call our tool data library. And what I can do is press the F1 insert tool and arrow over one time from this page. Right now it's telling me I have nothing in my tool library, but by arrowing over one time, the value of F1 soft key turns into tool set, and by touching that, it just automatically populates the entire library with generic tools. Now I can function, I can make my control function as normal. Just simply when it comes time to set a specific tool, I'll call that up, put it in the spindle, touch it off my stylus if I have a tool setter, or if I have a presetter, I could highlight, call up the offset category, and just set my tool value to whatever the known preset value is. In this case, let's just say this is a 4-inch tool, and now, boom, I've got a population in my tool offset library. That is all the more I need to do to get the machine to function. Everything that you see from here on in is optional and is just kind of fun so that I can see a depiction of what the tool is. I'm going to go after tool number 1 right now, and I'm going to populate it with the type of tool that I want to see. The first thing I want to do is populate a graphic of what this tool is going to look like. There is a library full of generic graphics that the OSP control has by default. Over on the vertical function keys on the right side of your screen, by touching the $sign, you'll get the highest level of the tree that I see here. And by touching the OSP key, I can come up with my easy modeling software. By touching that, whoops, I already started something. Yeah, let's get rid of that. By touching the easy modeling screen, I come up with the library of everything that is currently in my graphic library. I'm currently working on a machine that has our collision avoidance software, so you'll see that there are many different graphics I can create, from the blank of what does my raw material look like, my fixture, a set tool, that's a tool that's already been assembled, the tool itself, the cutting tool, or the holder. If this was not a collision avoidance equipped machine, the only thing I would see would be the blank and the tool. So, because the only thing I'm worried about, I'm going to imagine this is not a collision avoidance machine. The only thing I really want is the cutting tool itself, because that's what's going to be displayed in my graphic window and also in the description window. So by highlighting the tool category and now touching F1 new, I can now see a generic description of all of the different types of tools that the Okuma can make for me without having a solid model from a tooling distributor or any other graphic related to that tool. So in this case, we're going to turn this tool number 1 into a face mill. By touching that, I see a graphic representation of the cutter on this side of the screen. By touching OK, it opens up the parameters that are involved in this tool. Now you notice I've got a little descriptor down here right in the center of everything that is telling me exactly what they're asking for with each of these categories. My tool diameter for D1 is obviously the overall width of the cutter, so we're going to call that a 3-inch shell mill. My D2 diameter, as shown in the description, is the shank diameter. So let's say this is a 1.5-inch shank. My length is the physical cutting surface of the tool. So let's just say we have 1/2-inch inscribed circle inserts that are square. So all right, cool, there we go, 1/2 inch. The length L2 is the overall of the entire tool. And we'll tell that that's 3 inches. And I do have a choice from tool shape being standard, which is what I see in the depiction, or the option, which is showing me a like a high feed type cutter where I get to specify this engagement angle. In this case, we're just going to call it a standard cutter, and I also will populate how many inserts this particular tool has. We'll say in this case, okay, 5 inserts. When I click on the word OK, now I see a graphic depiction of this tool. I could move the graphic around, I could rotate it so I can see that it truly is what I want. When it is, I touch OK, and now it's has a registered picture of the tool, and I simply have to call it give the file a name. We'll say this is a shell mill. And once I say OK, now that shell mill, that 3-inch shell cutter, is in my tool library, and it will stay there forever. I don't have to create a new graphic representation of a shell mill unless something has drastically changed, like the diameter of the cutter or the address angle of the insert to the material. Now I could go through and I could show you all of the different types of tools, but they're pretty much self-explanatory as to what each of these tools are based on the graphic that you see on the side of the side of the window here. And really it's just a matter of expressing to the machine what each one of these cutters measures. In this case, we'll just cancel it out because now I have the graphic I want to talk about. This is the first level of where this tool exists in my graphic software. Right now it's simply a graphic in the Easy Modeling software. It is not applied to the tool at all. The second place to import this tool is in our Tool Data tab. I like to tell my customers that the Tool Data tab means that this tool physically exists somewhere in the building. It might be in the machine, it might be in a toolbox, it might be sitting on the boss's bench because he doesn't want to let me have it for fear of me running it into a vise or something. Tool Data tab simply means that this tool exists. So in order to populate the Tool Data tab, bring the tool from graphics to the Tool Data tab, I go into my Tool Data mode on the machine, touch the Tool Data tab, and now I'll simply register the tool data. The first question to bring up is, what is this tool number? Now, one of the things that a lot of people don't grasp about an Okuma, if you only have, say, 32 tool pots available in the magazine, that does not mean that you're only limited to tools 1 through 32, 33 if you count the spindle. I can call this anything from 1 to the maximum number of offsets that my machine currently has. In this particular machine, I've got 1,000 offsets. So I'm simply going to call this tool number 250. Now, the nice thing about doing this, particularly for a shell cutter, is that in general, the shell cutter may get removed from the machine, but its offset will never change. So by naming this shell cutter something well out of the normal range of operation, if I pull this tool out of the machine and set it in a cart and go back to it in 3 weeks' time, I can stick it back in the machine, express to the machine that I installed tool 250, and its previous offset will still be in my data page and will not have gotten erased, unless of course I had a different tool 250 for some reason. I have the opportunity, if I want, to apply a tool name. We'll call this a shell mill, give it a size. Just below the name, I have two of the cool options that the tool magazine can employ. The first is the diameter of the tool. Right now it's set to none, which means it's simply a standard tool and can have just about anything put next to it in the magazine that it wants. However, if I choose, I can call this a large diameter tool. What that means is when I install it in the magazine, the magazine will automatically blank off two pots adjacent to this tool on either side and will not allow any tools to go into that restricted area. This is kind of neat if I've got a large cutter because, yeah, I don't want to put anything next to it for fear of interference. It will also do a very wild tool change procedure. It will grab the large tool, the arm will swing in, grab the large tool, move to a neutral position that's about halfway between the magazine and the spindle, and then stop. It will then reorient the tool magazine so that it can put the non-large diameter tool in a pot other than the one that's been saved for this large diameter tool. It's a really neat process, and if you look on my channel, you'll see a demo, a video taken of this large tool change process. It works out pretty well. In this case, we're just going to say this is a none in the diameter type, no restrictions whatsoever. The heavy type, if I tell this is a heavy tool, it will automatically slow down the tool changer arm to approximately 50% of its normal speed. This is not just handy for a heavy tool, but say your probe is a little sensitive and you don't want to knock it out of calibration. If I flag it as a heavy tool, all that means is that the tool change is going to be at about 50% of its normal speed. In our case, it's a shell mill. We don't care. Just let it whip. Right now, I see no graphic here. There's been nothing assigned to this tool. So I am going to come down to find the Set Tool Model here under F4. When I touch that, it'll pop up a graphic window straight out of the easy modeling software from Okuma. Right now I have several different options that you won't see if your machine doesn't have collision avoidance. This select holder and select sleeve or define sleeve is for a tool bushing, and also for collision avoidance the machine wants to know what my holder looks like. If I don't have collision avoidance, the only thing I'll have at this point is select tool, and then of course all my little viewpoints here. So by touching Select Tool, it opens up the library that we just populated under this key, Easy Modeling. Select my shell mill, say OK. Currently, it's not oriented properly. Because this is a collision avoidance machine, it's going to try to look to the holder for orientation. But I don't have that opportunity here. I'm simply going to say OK. Not worry about the orientation because, well, I'm not physically using it, and if this was an actual CAS machine, the holder would have told the machine how to orient the tool. There's that graphic I was looking for, as well as the dimensions of the tool. Now by saying OK, my tool data now has 250, tool 250 as a face mill, and if I touch it, it populates the graphic right here. That's the whole reason we were doing this. So now we have this tool existing on 2 of the 3 surfaces. One in the Easy Modeling software, second in the tool data. But as I described earlier, this does not mean that this tool is necessarily in the machine. It just means it physically exists in the building. But now I want to put it in the machine. So I'm going to touch the Magazine Info tab, and because of that keystroke that I did at the very beginning where I did Insert Tool, arrow over, my magazine is completely full right now. So I'm going to need to select the pocket where I'm going to insert tool 250 and touch Detach Tool. It's going to ask me to confirm. When I say yes, now pocket 47 in my tool magazine is now non-exist. There's no tool in that particular pocket. So now I want to put my tool 250 in here, so I will insert the tool. When I touch insert, it shows me all of the tools that I own that have been populated in the tool data page that are not currently in the magazine. And there's my tool 250, the 3-inch face mill. So by touching it and saying OK, now the tool is attached in the magazine, and anytime I touch it, it shows me the graphic representation of that particular tool. And of course, if I were to call up that tool, T250 M6 or G116 if you're using the Okuma macro, I'll see the graphic go off to the side, and once the tool has gone into the machine, there it goes. Now my tool is represented in graphics. Now you notice it's sideways, but doggone it, I warned you about that because this is a collision avoidance machine and it didn't orient properly. But if this was a non-cast machine, that would have oriented as it was supposed to. And as this tool is cutting across a solid block of material, you'll see it accurately represented in your animated simulation. And again, that's the whole reason that we might want to do this process, so that we can see the 3D modeling over in the graphic window as we're moving along. Now, before I wrap this up, I'd also like to talk about creating a blank. When I do the blank, it gives me the opportunity of a basic shape or a rotated shape that you saw previously is it's for a casting. Basically, I just create a line, and that will revolve and make an irregular shape. But if I did want to use a basic square block, I could very easily just populate the size of my material, and let's call it -5. Now I will have a 5 by 5 cube. That's actually a 10 by 10 by 5 block. Assign my datum to where I want it through assign P0. Right now it's right in the center. That's good enough for me. So if I tell it that this is going to be work offset number 1, okay, now we're set. As I name this file, I definitely want to name it the same as my program name. I don't have a program here. Let's just call this test. The reason for that is when I select my program, I need to tell it that I want it to populate the graphic window with my block. When I touch Program Select as normal to pick up my program, now I want to call up this setup data and say, yeah, I want you to read that. It will find the block created in Easy Modeling that has the same name as your main program file name, and it will populate it in the machine. Reset. Because my block was labeled test and I don't have a test.min, alright, I don't get to see it, but now you get the gist of what's going on. One more time, I'd like to repeat that this is completely optional. If you don't care about seeing the graphic over here, and you don't necessarily need or want the graphic representation in this window, all of those steps are completely irrelevant. Right now, Tool 52 has none of those steps completed. All it is a generic number. I could put that in the spindle just as normal. T52M6 or G160, oops, not T2, T52M6. It will still put that tool in the spindle just as I wanted it to. I can now bring it down, touch it off of the tool setter, or I can manually input the tool data, touch it off the face of the part, whatever your prescribed method of tool offset acquisition is, and I can rock on. I just will not see a three-dimensional representation of the tool up here in the window. Hope this helps you out. If there's anything we can do, please feel free to reach out to your local Gosiger Applications staff.